In this lesson, I'll go through an overview of the App Components and APIs chapter. In this chapter, you'll learn how apps move through the phases of their life cycles and how to manage the basic flow of your app actions. The Android developers website has some great sections on components and APIs as shown here, and we'll be referencing them, and you should use them to supplement the information we explore in this chapter. A link to this entry page is included here. This graphic shows the overall flow of how app components and APIs are bundled together to function on mobile devices. Android application components, resources, and APIs are packaged and uploaded to Google Play and downloaded to devices and run on the Android operating system. We've looked at how you use Eclipse and the Android tools to develop the components, resources, and API references for your apps. We also looked at how you use Eclipse to create an APK or Android package that you then upload to Google Play using the developer console. Once on Google Play, device users can download the APKs to their smartphones and tablets. Device suppliers have loaded smartphones and tablets with the Android operating system. Let's take a closer look at how this works on mobile devices. The Android system is built on the Linux platform as a multi-user system. Each app is a separate Linux user with its own Linux user ID, and that ID is managed by the Android operating system and not known to the app itself. Permissions are set for all files in an app so that only the user ID assigned to that app can access them. Each app process has its own Dalvik virtual machine instance, which runs in its own Linux process. So one major aspect of this architecture is that each application is protected from other apps. There are ways for apps to communicate with each other, but unintentional cross-app damage is avoided. I've included a link here to the wiki article explaining this diagram, and a link here to the page on the Android developers website about app fundamentals. Let's take a look at a little more detail about Linux. Not only is Android built on the Linux platform, but the key element of app action, the process, is a Linux capability. Linux is open source software and was initially developed in the 1990s. Linux is a branch of the Unix operating system, and some changes have been made to the Linux kernel to support Android, but these are relatively small compared to the size of overall Linux. If you're interested in this background on Linux, I've included some links on the graphic. Linux processes encapsulate fundamental units of work. Processes which execute code are scheduled in a time-sharing mode with prioritization. You don't need to understand how Linux processes work in detail to understand Android apps, but it is, I think, informative to know where all that work your app is doing takes place. There's a link to a good overview of app processes here on the graphic. And now let's look at how Linux processes are used by your apps. One of the major concepts in Android is that of app life cycles. When your app is started by the user, Android starts a process that moves through a life cycle. The different types of components have different life cycles. That is, the phases the app passes through after it's initiated. When an app enters a given phase, life cycle methods are executed, giving the app the opportunity to carry out actions at that point. If you recall, we used the onCreate method in our first app to display our screen. As we'll see when we study the different component types, each component lifecycle looks a bit different than the others. We'll look in detail at the life cycle of each type of component in future lessons. Another important concept is that of threads. The main thread of an app is, among other tasks, responsible for the user interface. Work done by the app that might delay or interrupt the user interface should be done in a background or worker thread. One example of the need for a worker thread is accessing data across the internet. Delays in data transmission can cause interruptions of the user interface and should, therefore, be accomplished using a background thread. We'll be looking in detail at background threads in a future lesson. So that's an overview of the App Components and APIs chapter. Now on to lessons looking at the details of these basic building blocks.